calculate the maximum speed of the cork as it rises and falls in the water. Yeah, to get the surface tension to matter, you've got to go to much smaller wavelengths, and that brings this term up, and it brings that term down. Maximum speed of the cork. So in SHM, it's going to oscillate up and down. So WENS is going to be at maximum speed. It's going to be maximum speed at 0 amplitude. So if we plot cork position against time, it's going to do that. It's going to bob up and down by 0.2 meters. There's our time. So max speed is when displacement is 0. They're probably given this in the front. If not, you can work it out. Here's our equations. Yeah, my paper's stuck together. There we go. Simple harmonic motion. V is amplitude times omega times cosine omega t, where you've got a sine wave. So V max, as that is equal to 1, is just A times your angular velocity. So we know amplitude 0.2 meters. Omega is 2 pi times frequency. Now here's the question. What is the frequency of the wave? Well, we know our wavelength and we know our velocity. Therefore, we should be able to find frequency. So V equals the frequency times wavelength. So it implies F equals V over lambda. So V max, probably shouldn't confuse that with U. I should call that U, perhaps with the velocity of the cork. So again, that's a notation thing to bear in mind. Now that is a V for the wave. U for the cork is 0.2 meters, your amplitude, times 2 pi, your velocity over lambda, 0.2 meters, times 2 pi times your velocity, 3.9 meters per second. Over 10 meters. Right, I'm just thinking the units don't match, but they do, because the meters cancel, and now we've got a velocity left. Well, what does that come to? 0.2 times 2 times pi times 3.9 divided by 10, which of course I can do without a calculator, 0.43 meters per second. Again, sanity check, 0.2 times 6, so that's about 1.2 times 4, so that's about 4.8 divided by 10.48. Yeah, seems about right. Cork bobbing in water, 0.43 meters per second. It's quite a large amplitude wave. It's certainly not, you know, hundreds of kilometres an hour, and it's certainly not microns per second either. So it does seem a reasonable speed.